Welcome to our 13th recording in Computer Programming 1. Believe it or not, we're getting close to the home stretch now. Today we're going to talk about if tests, Boolean comparisons, string comparisons, and also some advanced JOptionPane. That might take, we might complete that in this one lecture, or I might have to break it into two. We'll see how long our discussion goes. After that, the next lecture series is going to talk about iteration and looping. And then after that, I will take your questions on what you find confusing, and I will go over it again, and then we're done. If you don't have any questions, if you don't submit questions to me, then what I will probably do is talk about exceptions, or I might talk about, I might talk about how color search works on plant places, how we can convert the world of analog, as in colors, to the world of digital, as in data, and how that works on plant places. So a couple options, but we are nearing the end of our lectures, and I did want to keep a little bit ahead. I know we have a very compressed quarter, so I wanted to keep a little bit ahead so that I didn't hold you guys up. So probably I'll have most of the lectures recorded in the next few days, except for that last one, which is your questions and answers, and then we're all set. We will have an exam this week, remember. I'll post more information about that as well. So, welcome from Mexico. One funny thing is that when I'm in Mexico and there's Google ads on a web page, they know I'm in Mexico because they put the ads in Spanish, which I found kind of interesting. So I heard there were some storms in Cincinnati this week, and obviously I missed those, but I saw all about it on Facebook. It did rain a bit today in Monterrey, Mexico, which is basically a desert town, so they don't get rain often, and they don't have large sewers to handle rain, so the rain just kind of collects like a pool in the street, and then people are afraid to drive in it. It's kind of like how we are with snow back home. So, in any case, I'm going to start with ucjava.com. I'll show you how I get here, ucjava.com. And I'm going to go down to Computer Programming 1, and we're going to take a look at conditional statements. These are the slides we're going to cover, conditional statements, and then the slides over here. First, though, let's take a look at the programming assignment. And again, well, these dates are coming up. This will be our last programming assignment, and what we need for this is we need to be able to use if tests and looping. So here's what we're going to do. You might have noticed in part 1 you had to prompt for a C or an F, but you didn't do anything with that. Well, in programming assignment number 3, we're actually going to do something with that. Also, you may have noticed that you had to have a set Celsius method, but you never called it. Once again, in this part, we are actually going to call it. So what you need to do in part 3 is change your converter runner to, you probably already have the prompt for C or an F, but make sure it has a prompt for a C or an F, okay? Use a while loop and an if test to validate that the user has either entered a C or an F and not a different letter. We'll cover that more when we get into while loops. If the user enters a C, assume the number is a temperature in degrees Celsius. Convert this value to a double, because remember, you're going to prompt, convert the temperature value to a double. Don't convert the C or the F to a double. You can't do that because they're not numbers. So you actually need two different prompts, which you probably already have. One for the C or the F, and one for the temperature. So two different prompts. So you're going to want to store the C or the F in a string variable. And then for the temperature, you're going to want to initially store that in a string because that's what you'll get back from a JOptionPane. But then you're going to want to convert that to a double, and then, or an int if you use an int, and pass that to the set Celsius method of the converter object. You should already have this method. You should have made this method in programming assignment number 2. Now, part 3. If the user enters an F, assume the number is a temperature in degrees Fahrenheit and call the set Fahrenheit method. So you see, you have to do a decision here. And a decision indicates an if test. If C, call set Celsius. If F, call set Fahrenheit. Okay. Then we have other decisions. If the user does not enter a temperature, assume a default value of 35. And then regardless of what the user has entered, invoke get Fahrenheit and get Celsius and print the output. Okay. Now, also, you'll want to loop and allow the user to do this over and over again. Again, we'll talk about loops in a later lecture. So, and then do something extra, and then we have the grade sheet down below. So that is programming assignment number 3, our final programming assignment. And what we'll take a look at now is how to do these conditional statements. What luck I have. I go to do a lecture and I get prompted to log in again. Okay, so you get to see my my super secret password, which won't do you any good because it only works in this hotel. Okay, but needless to say, there it is. Okay, let's try UC Java again. Hopefully it won't re-prompt me. And I need to resize this screen so I can fit it all in. Okay, and we're almost there. Okay, that looks pretty good. I'm going to click on Computer Programming 1, Conditional Statements. So a conditional statement allows us to make a decision. And I have a couple of examples here if you're interested. One is this prompt me example, the other is string manip. These are examples like you'll find on a lot of my slides of source code that's doing something like, here we have an if test. This is an if test that's comparing a string with an OR operator. We'll talk about all of that in a little bit. So, and as you can see, that's the date it was actually created, believe it or not, 10 years ago. So hard to believe a decade has passed since I created that. Also, I have one that talks a little bit about strings. I won't go over these in detail. I have another example that we're going to use instead. I'm going to pull the address bar up to give us a little more space here. There we go. Okay. Now, when I go to conditional statements, I'm going to look at if syntax. A conditional is a statement where we make a decision. All that we need for a conditional statement is one if test, and this is what an if looks like. Okay, let's say that day is a variable of type string. If we're comparing one string to another, we have to use a method called equals. So notice that we're using this variable day. On that variable, we're calling a method equals, and we're comparing it to the string Saturday. And we're saying, I'm off to Woody's to have a Grolsch. So what do I do on Saturday? Well, actually, I'm taping, I guess we don't call it taping. I'm recording this on a Saturday, but if it's Saturday, I'm off to celebrate and maybe have a cold one. Or whatever you do. Right now, that's what I said 10 years ago. Now I'd probably say I'm going to cut the grass. But nonetheless, that's what we do. That's the minimum requirement for an if test. This is called a single alternative selection because this line will print only if this expression between parentheses evaluates to true. That's the only case in which that line will print. If that comparison evaluates to false, nothing happens. Again, that's what we call a single alternative selection. If it evaluates to true, we print the line. If it evaluates to false, we simply don't do anything. So this is very important because this is something that a lot of people get confused about in an introductory class like this. An if test is going to have the word if followed by an open and closed parenthesis set. What is between those open and closed parentheses must evaluate to a true or a false. In other words, a Boolean must evaluate to a true or a false. So you have to have some kind of comparison because a comparison is something that's going to return a true or a false. Is 1 less than 3? Well, that's true. Okay, you're comparing numbers, but it's going to return a true or a false. Is 5 less than 3? No, that's not true. That's going to return a false. So whatever comes between the parentheses must return a true or a false. Now, that's the simplest if test. All if tests must have this if followed by an open and close curly. And what is in that open and close curly is what will conditionally execute if that if test evaluates to true. Now, let's say that we want to evaluate several conditions. In that case, we can chain if tests together. We start with our if, like so, but then let's say we want to take some special action if it's Friday. If it's Friday, maybe I go to Christie's and play trivia and enjoy a Hudie delight. So in that case, right after the close curly for the if test, I'm going to have an else if. And after that else if, I'm going to have an open parenthesis, a closed parenthesis, and once again a comparison. Then I'm going to follow that with an open and closed curly. And the statements between that open and closed curly will only execute if this evaluates to true. Okay? Now these are mutually exclusive. So if the first if test evaluates to true, it's going to skip everything afterwards. So only one of these will occur. Only one of these will occur. You can have as many else ifs chained to an if test as you want. You can only have one if, but you can have 0 to many else ifs that follow that. Now, one other thing you can have is an else, and that's a catch-all. You can only have one of these. You don't have to have one, so you can have 0 to 1 else's. That's just else without an if. There's no open and closed parenthesis that follows it, because this just means execute this line if all previous if tests evaluate to false. That's what we would call a dual alternative selection, which is we have an if test. If that expression evaluates to true, we do what's in the if test. On the other hand, if it evaluates to false, we do what's in the else part. So let's look at an example. This is the example. Here are some of the comparison operators that we're going to use. We have a double equals, an exclamation equals, less than, greater than, less than or greater than or equal to, less than or equal to. These comparison operators are only valid when comparing numbers. And you have to compare like types. You can't compare a number to a string. You can't compare a string to a number. So these operators are only valid for comparing numbers. If you're comparing strings, you have to use that dot equals method that we just saw. And this is one string object here. This is another string here. So we're comparing two strings. If case is not important, there's another method called dot equals ignore case. Use that if you want to do a case-insensitive comparison. Needless to say, if you're comparing numbers, these are the operators that you use. And each of these operators will return a true or a false. So let's walk through an example. Let's say I need to get downtown, and I count my change. I have $1.25, and I'm going to go through this if test. So in my cash variable, I have 1.25. Is 1.25 less than or equal to 3.5? Remember, it has to return a true or a false. In that case, it's going to return true, which means it's going to print ride the bus. Because the rest of this is chained together with else ifs and finally an else, none of the rest of these will execute. If this evaluates to true, only the first set of statements will execute. And certainly we could have more than one statement in here. It's just in this case, I just have one statement in each open and closed curly. Okay, let's say I have $5. Let's run through this again and say cash is equal to 5. Is cash less than or equal to 3.5? The answer is no, it's not. Okay, so we skip this. we skip the open and close curly, and we go to the else if. Is 5, is the value of cash, less than 6? Yes, it is. 5 is less than 6, so we park at the stadium, and again, as soon as one of these tests evaluates to true, it skips all the rest. So it's going to skip all the rest. Now let's say cash is equal to 6. I have $6. Is that less than or equal to 3.5? No. Is it less than 6? No, 6 is not less than 6. 6 is equal to 6. So now let's come down here. Is cash equal to 6? Yes. 6 is equal to 6. So we're going to say park at 7th and Sycamore before 9 o'clock. Next, let's say I have $10. Okay, so we run through this again. 10 is not less than 3.5, we skip that. It's not less than 6, we skip that. It's not equal to 6, we skip that. Finally, we come down here and this evaluates to true. Cash is less than or equal to 15. Notice though, something that's not written here is that for this to execute, not only does cash have to be less than or equal to 15, it also has to be greater than 6. Because if it were equal to 6 or less than 6, one of these previous items would have returned true, and this would have been skipped. So while it's not clear from the test here, not only does cash have to be equal or less than or equal to 15, it also has to be greater than 6. Similarly, for this to execute, not only does cash have to be less than 6, it also has to be greater than 3.5. If it were not greater than 3.5, this would evaluate to true, this line would print, and all the rest would be skipped. So when you see an else if, not only does this have to evaluate to true, but all prior tests have to evaluate to false. So be careful how you order these. Okay, so if I have $10, the previous tests are false, and this one is true, and we park at Fountain Square. Okay, finally, let's say I have $20. First one false, second one false, third false, fourth false. It goes to the catch-all, the else part, which is take a limo. So that is how our Boolean operators will work in an if test. Now think about that. Think about an if test in your life. What kind of times have you seen a program that makes a conditional decision? I'm sure you can think of an example. Maybe if you use TurboTax and you go through, there are a lot of questions there that are leading you into conditional decisions. I saw one today. I went to a museum here in Monterey. The first question on most of the kiosks in the museum was English or Spanish. So it made a decision. Then the kiosk I was looking at had me set parameters on, it was a steel museum, had me set parameters on what temperature the steel should be and what should be mixed in it, boron, carbon, magnesium, so on and so forth. And basically I would have to go through and answer these questions to make a certain kind of steel. So you can think of software all the time that is asking you questions. One that I've experienced recently is, well, I sold my truck and at some point I'm going to have to get a new one. I honestly am carless at the moment because I don't need a car because I'm not home. So needless to say, I was looking here at Tacomas and we see there's a lot of decisions that we have to make here. So, okay, let's say I want a double cab 4x4. Okay, if I get the double cab 4x4, then I can't get a 5-speed manual or 4-speed automatic. I have to get the 5-speed automatic, and I can't get the 2.7 liter. That's what these little I's mean. If I click on it, then it says, oh, you're going to have to change these other options. If I go with a long bed, I have to get 4x4. I can't get 4x2. If I go with a standard bed and a double cab, okay, that will allow me to get the 4x2 pre-runner or the 4x4, but not the 4x2. So we see all kinds of decision logic that's executing as I click these different options. If I get the access cab, and forgive me, it's a little bit slow here. I don't know why. Okay, if I get the access cab, I can get the 4x4 or the 4x2, but not the 4x2 pre-runner. And then if I get the regular cab, well, I have to switch my engine, and we'll see when that happens. I can get the regular cab in a 4x2 or a 4x4. All kinds of different iterations and configurations. So what I would like to do is model this in NetBeans. I want to model, let's take just the cab type, the drivetrain, and the bed length, and let's model a little decision engine to tell us whether this is something we can buy or something we cannot buy. So I'm going to go to NetBeans now, and I'm going to choose New Project. We'll make this different from the driver application we've been working with. And I'm going to choose Next, and I'll say Truck Builder. Okay. And I want a main class. I will call this Truck Builder Build a Truck. The main class is going to be the user interface class, remember? It's going to be the thing that interacts with the user. So I'm going to choose Finish. Okay. Now I have my Truck Builder, Build a Truck. I'm going to right-click, choose New, Java Class, and the first thing I want to do is create my noun class. In other words, the class that, the truck, the class that's going to have attributes and methods and the like. I'll simply call it truck. Okay? Now, think about the attributes of a truck. And to be honest, there's an easy way to think about this. Look right here. These are attributes of a truck. Cab type, drivetrain, bed length, transmission, engine. Then we have options, colors, so on and so forth. Those are attributes of a truck. So those are things we can model here. I'm going to resize NetBeans a little bit to make it fit in the window a little bit better. Let's see how well I can do this. There we go. Okay, so just a reminder on how to create this. This is a lot like your converter class. I will say string cab type, string drivetrain, string bed type, long or short. I could do that as several things. I could do it as an int or we'll keep it as a string. String color, and I could keep going. Okay, now remember it's very easy to create getters and setters. We simply choose refactor and encapsulate fields. Comments on programming assignment 2, the ones I've looked at so far, some people are a bit confused on getters and setters. For Fahrenheit, this is all you need to do. For Celsius, you need to make the getters and setters, and you need to put one formula in get Celsius and the other formula in set Celsius. That's what your converter should look like. So I choose encapsulate fields, and I'm going to go ahead and select all. I'm going to say change the fields to private and make the getters and setters public. And then I choose refactor. And at this point, my truck is pretty much complete. I'll go ahead and make a toString method. So public string toString, this is always a good idea. Open curly, close curly, return your new truck has drivetrain plus drivetrain plus bed type, let's say bed length, plus, whoops, sorry, went to a new line, plus bed length. Is that not what, a bed type, sorry. Plus, okay, now this went off screen, so I will scroll over in just a moment. Let's see, bed type, drivetrain, and cab type. Okay, plus cab type, and plus cab type, and semicolon. So that's what the balance of the line looks like. Okay, so we're simply going to assemble this string and return it, and I'll go ahead and choose Save. Now I'm going to go to the Build a Truck, and what I want to do here is I want to prompt the user through a series of questions and then ask, is this, well, I won't ask the user, I'm going to tell the user either this is a valid configuration or it's not a valid configuration. Now we know the main method is typically where we start our program, so we want to keep that fairly small. So I say main, and then I'm going to say public static void prompt user. Okay, open and close curly to make sure I have a valid method. And then from main, I call prompt user. Okay. And of course, I want to put some java comment here to say prompt the user for truck options, then display either a valid truck or an error message indicating that the selections are not valid. Okay, there we go. So I'm going to save. And now I want to explore how to prompt the user with JOptionPane. Now, we know we've used JOptionPane before, but let's look at some better ways to use JOptionPane. So far, we've just allowed the user to enter any text. Generally, if we can somehow validate the text that the user enters, or actually give the user some options from which to choose, some predefined options, we're going to have a better chance at getting valid data. So I pulled up, I did a search on JOptionPane, and when I look here, I see show input dialog, and notice that this is an overloaded method. Now think about overloading. We spoke about this with constructors. Same thing applies to methods. Overloading means we have multiple methods with the same name but different parameter lists. Multiple methods with the same name but different parameter lists. We can't have two methods with the same signature. And the signature is defined as the return type, the method name, and the parameter list. So as long as we vary the parameter list, we can have different methods with the same name, as long as the parameter list is different. And so far, for show input dialog, we've been using the very most basic signature here, which is where we simply pass it a message and it returns a string. It's static. Now think to yourself what static means. Static means that we don't have to create an object to call this method. So static, it returns a string, the name is show input dialog, and it accepts a message. Let's look above at this other signature. Show input dialog, which returns an object. Now we need this parent component. That's kind of weird. That means what screen do I belong to? We're actually doing everything on command line, so we'll leave that null. Don't worry about that. Then we need a message, and then we need a title. So we're going to get not only a message, which we've seen before, we also now have the option to display a title. We have a message type, which would be something like a warning or a question or information. Or we can specify an icon. We don't need to specify both. So we're going to specify a message type, and we're going to leave the icon empty. Here's what we really want, though. We can pass an array of predefined values, and the user simply picks from one of those. So we provide an array of predefined values, and the user picks from those. Now, what's an array? We haven't spoken much about arrays, but an array is a collection of multiple pieces of data of the same type. You might remember our string example where we use the split method on string to split a string into its constituent parts wherever it saw a specific delimiter. In our case, the delimiter was a comma. We saw an array then. We didn't talk much about it, but we'll make another array here. Okay? And then we also want to say what's the initial value we're going to show the user. So notice we have far more pieces of information that we need to pass this signature than we're used to. But the bonus is we're going to get a much nicer show input dialog. So let's give it a try. Okay, first I need to define the values. So I'm going to say string, and for the first one, let's say all cabs. Now by cab, what do I mean? Well, let's visit our URL again for Toyota. And the options are regular cab, which is just a door, access cab, which are the suicide doors, or double cab, which is 4 full doors. So that's 3 options. I'm gonna say string all cabs equals new string square bracket 3 close square bracket terminate with a semicolon. What are the square brackets? It means it's an array, which means it will hold multiple pieces of data. Okay? And the 3 indicates we're going to store 3 pieces of data. The tricky thing about this is, naturally being programming, even though we store 3 pieces of data, they're labeled as 0, 1, and 2. So be careful. Remember, we start counting with 0 in programming, not 1. So then I'll say all cabs 0 equals regular cab. Okay, what I'm doing is I'm defining the first element to be regular cab. Okay, I'm saying the first of these array elements is going to be regular cab. So this is what we call an index or a subscript. It says that in our string array, we want the very first string to be regular cab. Now the second string, all cabs 1 equals, let me space that out the same way, access cab. Okay? And then the third string, all cabs 2 equals double cab. Okay, now that we have this string array, let's try that JOptionPane with the enhanced signature. So I'm going to say JOptionPane, and I stress here, very important, pay attention to capitalization because this one is tricky. Capital J, capital O, capital P, all must be one word, no spaces. And then we put a period, and then show input dialog. Okay, and I was hoping it would give me the context-sensitive help, but you know what? It doesn't know who JOptionPane is yet. So I'm going to click on the light bulb, and I'm going to say add import. Now that I've imported JOptionPane, now let me try that again. Show, come on, don't do that, come on, show it to me. Show input dialog. And see, this is falling off the screen, but it's kind enough to show me all of the different signatures for the method name show input dialog. In other words, the different ways we can call it. And the one we want is the one at the bottom. So I'm going to go ahead and hit enter. We'll leave the parent screen as null. We don't need to specify that. Okay. The next is the message. Okay, let's see, message, and I have to make sure I get this right. Okay. Or no, I'm sorry, the next one is the title. So what I'm going to say for the title is select a cab. Okay. The next one is the title. Well, shoot. Looks like I got that one a little bit backwards. Okay. This should be select a cab. The previous one I'm going to say choose a cab from this list. Okay, there we go. Now that looks better. Now I'm going to scroll to the right, and for message type, this one's a little bit tricky. I'm going to say JOptionPane dot question message. This isn't very obvious, but what this is doing is saying make this a question message. In other words, put a question mark on there. For the type, we have to pass in one of these things called a constant. The constant is defined on the class JOptionPane, and this constant is the question message constant. That means display a question mark in the JOptionPane to show that it is a question. Okay? Now, the collection of options I want to send to the user is that all cabs array. I made it first. The default value, let's see if I can get this on screen again. I'll just say the first element of the all cabs array, and then I'm going to terminate with a semicolon. That was quite a mouthful. Let me go over it again. JOptionPane show input dialog. First argument's null. That's not going to apply for us. Then I have the message I want to display to the user, which is choose a cab from this list. Write that down because we're going to see that in just a second. Then I have the title. Write that down. We're going to see that in a second. Then I have some goofy syntax here, but basically what I'm saying with the goofy, no, come on. What I'm saying with the goofy syntax is make this a question, so put a question mark on the dialog. Then something we don't need to worry about, we leave that as null. Then the collection all cabs, which is that array, the array of predefined cab types. And then the one I want to appear in that drop-down by default, which is the very first element of that array. Okay, again, that's a mouthful. Let's go ahead and run this and see what it looks like. Okay, it's compiling now. We'll let it compile. It'll take just a second. It'll run. Now, look at this. Select a cab. Remember that? Down here. Choose a cab from the list. Remember that? There's our question mark. You might remember that. We had JOptionPane.question message. And then take a look at what's in the drop-down. Okay, and notice which one was picked by default, regular cab. So let me go back and let me change the default. Let's say I want access cab to be the default. I'm going to change it to the one element, which is this guy right here. Okay, I'm going to save, and I'm going to run this again. And notice now access cab is chosen by default. Okay, so this is a different prompt than we've seen before. This is a bit of a different prompt. Okay, what we're going to need to do now is we're going to need to store this in a string variable. So I'm going to say, well, gosh, the problem is this doesn't return a string. So we have to get a little bit tricky. I'm going to say object obj cab type equals JOptionPane show input dialog. It returns an object, not a string. Then I'm going to say string str cab, let's say, I'll just say selected cab type equals obj cab type dot toString. A little trickiness there. Why does it do that? This is just a more intelligent JOptionPane, and what it is actually doing is it's returning whatever the user selected from this collection. In our case, that happens to be a string, but the JOptionPane doesn't know that. So it returns things as a more generic type, and then we have to tell it, oh, actually that is a string. There is another way we could do this, and that involves casting. I'll try casting. Let me see if I can get casting to work. That might be a bit more straightforward. String selected cab equals string, like that. Now what we're doing is saying, I know this actually has a string in it, so I'm going to make it a string when I get it back. Just to make sure we got it right, let me do a system out print line, selected cab, colon, and then plus selected cab. Okay, I'm going to save, and I'm going to run again, and let's see what we get. Okay, I'll change this to double cab, and then I'll choose OK. If all worked right, we should see double cab in our standard output. Okay, I scroll up, try and move that up, and notice that sure enough, selected cab, double cab appeared correctly. This syntax worked for us, so we'll continue to use this syntax. Okay, let's do the same thing for bed length and the same thing for drivetrain. Okay, so I'll say string all drivetrains equals new string 3. Okay. Okay, it has to be square brackets over here as well. All drivetrains 0 element equals 4 by 2. Remember that one? All drivetrains 1 equals 4 by 2 pre-runner. Okay. All drivetrains 2 equals 4 by 4. Okay. String selected drivetrain equals, we'll cast a string, and then we'll do our JOptionPane show input dialog. Choose the last one, and 1 second please. I'm trying to get this so that it all stays on the screen, which isn't very easy. Okay, first we need a message. We'll leave the null there as the first argument. Second argument, we need a message, so I'm going to say choose a drivetrain from this list. Okay, next argument is going to be the title, and I'll say select a drivetrain. Next argument is going to be that goofy syntax to say I want a question mark. So JOptionPane dot shoot, and this fell off screen, but there are actually a lot of different options. We have information message, we can use that. Plain message. I'm going to choose question message. Okay. And then null, that's fine. All drivetrains, that's fine. And then the default will say all drivetrains 0, and then we'll terminate with a semicolon. And there we go. So there's our selected drivetrain. Okay. And finally, let's choose the bed type. So we'll say string square bracket all bed types. Really should say length actually, but that's okay. Equals new string, and we'll make that length 2. Okay. All bed types element 0 equals short bed. Okay. All bed types 1 equals long bed, and terminate with a semicolon. And once again, string selected bed type equals, put our cast to a string, and then JOptionPane dot show input dialog. Okay, null, comma, choose a bed type, comma, I'm sorry, choose a bed type from this list. Okay, next argument, choose a select a bed type. Okay, next argument, JOptionPane dot question message. Next argument null. Next argument all bed types. Next argument all bed types. We'll leave short as the default. Okay, and let's go ahead and do a. I'll move my system out print line to the very bottom, and we'll add the selected bed type and selected drivetrain to it. Okay, plus selected bed type. Okay, selected bed type plus selected drivetrain plus selected drivetrain, and terminate with a semicolon. All looks good. Okay, I'm going to save and run, and we'll make sure we get predictable output. After that, we get to look more at if tests. So I save and run. Okay, let's change this to double cab. Let's change it to 4x2 pre-runner. And finally long bed. And let's take a look at our output. Selected cab, double cab. Selected bed type, long bed. Selected drivetrain, 4x2 pre-runner. Everything's looking great. We now have our local variables populated, and we're ready to create a truck and make some if tests. Well, we are coming up on the 45-minute mark, and about that time I start to get nervous that I'm accidentally going to do something to delete the recording. So I'm going to save this recording, and we'll pick back up on the next recording and look at how we can use this in if tests. Thank you.